hope y'all are all having a good Thursday and staying warm and avoiding the outdoors. I'm just about to jump right in because what can you say other than we're about to talk about z-scores. So, real quickly, if we review what we talked about on Tuesday, recall that we learned how to calculate variance, which is just a way of quantifying variability in a sample. And then we learned how to interpret variance as the average deviation from the mean, aka using the standard deviation. So when we originally calculated variance, we had to take the average squared deviation score, and then to make that more interpretable, we took the square root of variance to calculate the standard deviation. And remember, the standard deviation is just the typical deviation from the mean, or saying on average for those who did differ from the mean in our sample, how much did they differ? So it's meant to estimate the average size of the deviation scores. What we're going to talk more about today and the next class is how we can use the standard deviation for bigger and better purposes. So mainly we're going to learn how to use the standard deviation to represent individuals in units of their deviation from the mean. And we'll do this by calculating standardized deviation scores for each person, which is just another way of saying we're going to be calculating z-scores for each person. So a z-score is each person's deviation from the mean, but it's been standardized. And then after we learn how to calculate z-scores, we will use those to start estimating statistical relationships, or in other words, we're going to use the z-scores on multiple variables to look at shared variance between two variables or two things. So we've already calculated a deviation score in terms of the raw units on our scale. So what this means is we've calculated raw deviation scores. Those are numbers that represent the difference between a person's score and the average. A raw deviation score, just like when I referred to raw scores, that means I'm always talking about scores that are in units of the original scale. So if I ask participants, for example, to rank their perceptions on a scale of 1 to 5, then the raw units, we know, range from 1 to 5 points. So here is a metaphor that might be helpful. Raw scores are like a raw steak. They have not been cooked, they have not been touched, they're just steak in its original form, okay? Similarly, raw scores have not been transformed, they have not been changed or modified in any way. By comparison, standardized scores are like a steak that has been cooked well done. They have been changed from what they were originally and transformed or modified into different numbers. However, the numbers still represent the original distribution of scores that we observed. So that hasn't changed. Just like when you order a steak and you ask them to cook it medium, medium rare, well done, or whatever, you're still eating a steak. So, when we standardize a score, that means the person's score is no longer in the original units of the scale. Instead, it's now in terms of something that we'll call standard deviation units, which means essentially it's in units of the standard deviation. So we'll kind of unpack that and make sense of that a little bit more throughout the lecture and class. So when we estimate the standard deviation of the sample, that is allowing us to take each individual score in the sample and calculate it in reference to a standard. So as I said, now we can know how a person scored, not just relative to the mean, but relative to everyone else in the sample. So remember on Tuesday, we calculated the standard deviation of the sample. That value is estimating how much the average deviant differed from the average person in the sample. So in other words, it's saying, for those who did differ from the norm, or from the mean, I should say, how different were they on average? So the standard deviation statistic, S, is one number representing an entire sample, or describing an entire sample, describing an entire distribution of scores. We can use that one estimate to then standardize each person's scores, which means each person in the sample will have a unique standardized score.